Hello guys, welcome back to another video in the Finance with Python series. This is Anirudh here, and today we are going to be looking at an introduction to Pandas. So we are going to be taking the ICICI Bank stock data, and we will do some manipulation over this data, and I'll show you different functionalities of Pandas using this. And I highly recommend you to watch the previous video that I had made on the Y Finance library just so that you know what Y Finance is and how you import data from it. So now let's get started. So here I'm just going to install Y Finance and import it, and I'm downloading the recent data of ICICI Bank stock for the last 1 day with an interval of 1 minute. So I've just taken the last 5 values of this stock just before it closed. You can, if you want to visualize the whole data, let's just say data one. So it opened at 3:45. This is according to the UK standard time. India is 6.5 hours something ahead. So you can calculate it accordingly. Plus 5:30, yeah, 5.5 hours ahead. So that's when Indian market starts and it closes at 10 according to the UK standard time. So anyways, leave that. So now let's import pandas. And now what we're going to do is let's just look at some basic functionalities of pandas. So what is Pandas? Pandas is a very important library that contains a lot of data structures and data manipulation tools that is designed to make data cleaning and data analysis very fast and convenient in Python. And Pandas is often used along with tools like NumPy and SciPy and a lot of other analytical libraries like stats models, scikit-learn, and so on. Pandas has two main data structures. One of them is called as series and the other is called as the data frame. We are going to be covering data frame extensively in this video, but let me just tell you what a series is. So let's quickly define a new series. Series. So this is a series. So as you can see, I have defined a series over here. And for each element of the series, you are given a corresponding index 0, 1, 2, 3. So series is like similar to dictionaries, and each of these, data values have a corresponding index associated with it. And that is what you are visualizing over here. So this is a basic series. So you can think of it like this. The counterpart of series in Python is a dictionary. And if you want to access elements of, a series, it's called obj. So obj of 1, you'll get 5. Yeah, took a bit of time, but it does work. Now, you can also do slicing over it, and you'll get 5, 6, 7, so on. So you can do all sorts of stuff like that. Just leave that here. Mm. Okay. Now you can also specify, you have these indexes 0, 1, 2, 3. What you can also do is you can also manually, sort of give an index for it for each of these elements, corresponding elements. So you can say X, and can have this the next value as Y, with this Z, now this is A. Now you can see that the indices have changed. So now I can also object of X. You can, oh, sorry, then this should work. Yeah. So you can reference elements from the series like this. Let's see if this works. Yeah, this also works. So let's try something more interesting. So, okay. So you can also perform slicing operations over the series in this manner. Next, let's also look at, so if you want to print the indexes alone. So you can just say object dot index. You'll get the data type as object and the index values x, y, z, a, so on. So this was very these are the very simple basic stuff. Now, if you want to alter, one of the values over here, let's say I want to change z as -2. So you can say obj of z equal to -2. Done. And print obj. Yeah. So, you can do this also. Just, changing values over here. This is something more interesting. Now, let's say you want positive numbers from obj. So you want, let's say, y, which is 5, and a, which represents 7. So you want these two elements alone. You can say obj greater than 0. Yeah, you get 5 and 7. If you want something that's, lesser than 0, negative ones, it's also you get it. You can also multiply it by 2 and, obj into 2 plus, let's say, 3. Let's see what happens. So we multiplied the whole thing by 2. So -8 plus 3 minus 5. Yeah, perfect. So you can do such arithmetic functions over this series. So the main idea of pandas is, you can do a lot of manipulation with different types of data easily. That is why pandas is very useful. Mm. You can also convert, the pandas series, the series data structure to, a list data structure. So you have object. So you have obj. Obj is an object, or you want to convert this to a dictionary and do that. Uh, Run it. You want to store this in something, obj1 and obj underscore dict. Yeah. Now obj underscore dict. Yeah. So this is also possible. I'm just showing you right now some, very basic functions of pandas and something that should be known. Mm. Now let's yeah. Now let's look at um the now let's look at dealing with null values or missing or NA values. Okay, so now let's just define another series, null series, let's say panda dot series of well, let's give -4 null. Oh, sorry, it's np dot none. I can also give it as none. None, let's say 6, 7, give indexes to it. Uh, yeah, let's just do this. So you can see that, y references a null value or, an NaN. So now if you want to see how many, if you want to, check if there is an NaN value in this, say null underscore series dot is NA. This should work. Yep. Is NA. So you can see that at y it gives true. So y is an NA. And not NA, it's like the opposite of is NA, obviously. So X is not an NA and so on. So you get the brief idea. You can also give it as is null. So that also works. You can use all these 3 variations. Now we have looked at, we have looked at series data, the series data structure. Now let's move on to the data frame data structure. We have another, data structure in Pandas called as the data frame. So this is basically a rectangular table of data which contains an ordered collection of columns and each of which can be, a different value. This data frame is more like a table and it has both a row index and a column index. And it can be thought of as a dictionary of series, all sharing the same index. Now let me just try to use a data frame like this. Data DFF, yeah. So this is how a data frame is, defined. So you can see here that, it is a dictionary of different series. So this over here is a series, this over here is a series data structure, and this over here is a series data structure. And the dictionary of the combination of these series data structures forms a data frame. In simple words, data frame is just, like a table format in which data is embedded, and you can do some magic on, the data stored in the table. And, you can this is really helpful in, data analysis and data cleaning and a lot of, data manipulations. Okay, now let's look at DFF. Um, Now you want to convert this into a data frame, right? We could have just done that here. So pt dot data frame. Yeah. And now just visualize DFF. Yeah. So now you get this, beautiful looking table over here. So evidently you have rows and you have columns, as in, okay, so these are called as the column references. So state, year, and pop are, the columns of it. And 0, 1, 2, 3, 4, 5, these are the indexes of, this data frame. So if you want, to change the column names of this data frame, what you can do is you can just say you take another data frame, pd dot data frame of the original data frame with index, sorry, it's changing the columns. So you say columns equal to, well, you can just use, we had state here, pop here. So we can add on saying state, year, pop, population, and you can also say mortality. You haven't explicitly given, values for mortality over here. So let's just see what happens over here. Since you haven't given values for mortality, what happens is it just references it as NaN. So now let's say you want to update a particular, mortality. Let's say the mortality at well, Nevada. Okay, so let me try this. This works. Okay. So now let's look at frame. Let's just do this. Yeah, let's look at yeah. So you can see that the mortality has become, okay. We have a problem here. Okay. So what has happened is everything has gotten, updated to, mortality. Okay, let's try that again. Dot yield. Let's try that again. Okay. Now we need to take this off. We don't need this column. There was a brief error I made here. So I'm going to also be talking about the LOC and the ILOC, functions. So LOC is basically a locate function. So if you want to locate any particular element in, the data frame, you can just say locate the data frame dot locate, and give the row index and the column index. So here the row index is 3 and the column index is mortality, and you want to reference it to 100,000, and now we reference it. You get it, right? So we want to drop this column because, it's undesirable and made a mess out of it. So what we're going to do is, yeah, so we finally, managed to drop this column. You can just, store the, name of the column on a variable and use the drop, keyword. And then, yes, you've successfully dropped that, column from the table. Okay, so now you can also do this dff.describe. So this gives you the count, mean, standard deviation, minimum, 25, 50, and 75, 75%, the maximum, and so on. Now let's try to, work with some stock data now that you've, learned some basics. there is a bit more that I need to cover. Data one, data one on this drive. Okay, now you get this information. So if you just want, a brief, understanding of how the stock is performing, you can just say data one dot sample. And it gives you a random value. And if you want to sample a specific number, give the number and you say, you get very varied, different prices at different times. And not that useful, but sure, you can get an idea. Data one dot info. Let's see what info gives you. So it gives you what all column names you have. Okay, now let's do something more interesting. Let's say you want the adjusted closing price alone. So let's say adjusted underscore close equal to of and now you want this alone and you want it's just sorry, let's just print this. There's a lot. Okay, let's just print the last five values. So here you can get the adjusted closing price of the ICICI Bank stock alone instead of every other thing. Let's look at how to filter the data based on a given condition. Yeah, filtering. Filtering is something you could do on the stock. So filter equal to, let's say you want you know specific time periods when the ICICI Bank stock went above. Let's say here it's 1265. Let's look at this. Okay, it was maxed out. The highest was 1285, and let's look at the 50th one, 1263, 1266. So let's look at when it went above 1 to 1275. Yeah. So that looks like a good price to sell from what I see. Do you see any 1275 out here? Uh, Not really, but okay. Let's go over. Let's filter data. Find when the stock went above 1275. So data one of adjusted closing. Yeah. Let's take the adjusted closing. Okay. Filter equal to data one of filter the data. Now print. Let's see on what all instances. Okay, a lot of instances. So let's give a more higher value. Okay. Oops. Hmm. So on all these instances, the stock value went over 1279 rupees. Now, if you want to access multiple columns, it's just the same as accessing one column. So let's say you want to access adjacent close and volume. You can just reference it as data one of take adjacent close of ICICI Bank. So now you can just give us you want these two particular columns. Yeah, let's show these columns. Now you get these. You can access multiple columns, so that is possible. We've looked at filtering data. Now, okay. Now, if you want, to create a new column on this, so let's call it, a difference column, the data one of difference. You want some sort of difference. This calculates, the difference between the high and the low. Data one of data one of low and data one dot tail. Yeah, let's try this. Works. So we have successfully created a new column over here. So we can get minute by minute, the difference between the high and low. You can also see this is a very basic thing that I've done here. But if you want to interpolate more results from these values, these particular values, using volume, open, low, high, close, adjacent, close, and so on, ADJ close, adjusted close, you can do that as well. Mm, let's also create another you know thing called squared adjacent close, right? Let's say this is data one of adjacent close. So what you want to be doing is squaring every value. So you can do this. You come on tail. Let's see if this works. Yeah. So you have the difference column, you have the squared adjacent close. You have also given a square root. The square root should be appealing to the eye. What is the error? What happened? Yeah, works. I think there was some particular value where it was less than zero or negative, and because of that reason, it just gave any values. So I think you just confirm that. So you can just use an NP where to give a conditional statement saying wherever it's greater than zero, compute the adjacent close square root, or input it as an NAM. Simple enough. So now the last thing that I'm going to be covering is the rename function. So if you want to rename this, so I've obviously made a bad spelling mistake over here. If you want to, rename this, you can say data one dot rename of it's a column. So columns equal to, and let's just copy this. I want to correct the spelling mistake. So that's my intention. And now let's give the right spelling as here, adjacent close, right? So you've done this. And now you can give the in place argument and give it as true, so that it directly references it to the data frame instead of just showing it as a new data frame. Here you can see that the spelling mistake has been corrected. There is also another function called as the value count. So data one, let me just show you how that works. So if you want to drop a particular column, you can just give the drop command. This will drop this whole column. Yeah, so the column has been dropped. So data one data one of adjacent close. You want to count the number of instances when the adjacent close price went greater than 1 to 75.0, 375 instances. So This was just, a brief. So I think I've covered, a lot of useful, functions and options available in Pandas. There are some, small things that I didn't cover, like how do you import, data from, a CSV file or an Excel file. These are, very basic, and you can just, you know, let me just show you the format. You have a lot of formats to import data from. So you have the CSV, you have the Excel file, you have the Parquet file. Parquet, and Parquet is very popular because it uses very less memory, so on and so forth. So let's say you can reference something as data two equal to, and you can just give pt dot read underscore CSV and give the file location in the brackets, and you can easily import any sort of, you know, file. So let's just look at the different, options available here. You have CSV, Excel, Feather, HTML, JSON, Parquet, so on and so forth. So that's the small thing that I wanted to show you. So I think we have, sort of covered all the basics that's required. This should be a good, you know, stepping stone for you to learn advanced stuff. So something that I would like you guys to look at is, looking at rejects expressions. Uh, that has a lot more functionality involved. You can do a lot more of data manipulation using that. So that's something that I would advise you guys to look at, rejects expressions. Apart from that, we have covered a lot of basic stuff. We have used, by finance, imported the data, filtered it, accessed, particular elements, and put up new columns, so on and so forth, using, the stock data. We had also looked at, basics of pandas like series, data frames, you know, accessing a particular element, changing the index, changing the column name, dropping column, locating a column, and so on. So that's all for this video. I hope you guys enjoyed it. Do look at rejects expressions. Pandas are very important. And that's all for this video. Thanks a lot for watching. Thank you.